Welcome back to Pre-Algebra, guys. I'm Miss Betsy, and I'm so glad that you're with us today. I'm using as my text Pre-Algebra for Christian Schools by Bob Jones University Press. You can use any text that you want to that's pre-algebra. The concepts and things that we're learning about are the same. We're in section 1.3. Today we're going to just be talking about equations. We're just setting the groundwork, getting some definitions and some properties under our belt before we really get into pre-algebra. First, I've got my lame jokes for the day. Another one of these old books that I grew up with. See, the orange spotted cow. Why does a cow go over the hill? Well, because, of course, the cow cannot go underneath the hill. And when should you give elephant milk to a baby? Yes, you're getting it figured out, aren't you? When the baby is an elephant. So those are your lame jokes for today. Let's go ahead and do a very quick lesson here. Nothing much to it. More definitions. What is an equation? Well, an equation, if I can open this pen. An equation is a mathematical sentence that includes an equal sign. This, then, is an equation. 2 plus 4 is equal to 6. Simply an expression if you have 2 plus 4. You add the equal sign in, says what it's equal to, then it becomes an equation. 2 plus 4 is equal to 6. What if I said 2 plus 4 was equal to 7? Well, hopefully you're going, don't think so. So this one is true, and this one's not. Well, look at this. True equation, false equation. Something that is just perfectly logical. It's an equation simply because there's an equal sign there. If it's true, it's a true equation. If it's not so true, then it's a false equation. Now remember, something that makes an numerical expression different from an algebraic expression. Algebraic expressions contain variables, which are letters that can be used to represent different numbers. So, an equation that has a variable in it, x plus 5, is equal to 9. This is something that we simply call an open sentence. More vocabulary, guys. We don't know if it's true or false because we don't know what value we have picked x to be representing. Now you know that we don't have to solve this at all. You know x plus 5 is equal to 9. Something plus 5 is going to be equal to 9. Well, x is 4. So if we have some choices, and you very quickly obviously see that I do not do set notation well. I don't draw those braces. But this is my replacement set. For here it says, okay, these are the possible answers. This is our replacement set. Our replacement set contains the values 4, 5, and 6. What happens when we put 4 into our equation? Well, 4 plus 5 is equal to 9. Okay? What happens when we put 5 into our equation? Hopefully you're just saying, well, this is like so obvious. Miss Betsy, why are you even bothering to write this out? Well, because it makes me feel good. 6 plus 5 is equal to 11. Okay? But we're putting our substituting in, so is 5 plus 5 equal to 9? 6 plus 5 equal to 9? No. So the only value from the set of possible values for x that works for this, of course, this is the only true equation we have. So if I say, use the replacement set, I say solve the open sentences for the replacement set. That means, look at this replacement set right here, 4, 5, and 6. Which one, if any of these values, makes this a true equation? Well, you solve it, and 4 is the only solution. 5 doesn't work, 6 doesn't work. Well, what happened if we had our possible replacement set? Our values that we could have would be 3, 5, and 6. Are any of these going to work in here? No, none of them work, so there would be no answer or no solution. So we have true equations, we have false equations, and we have open sentences. Now, let's see what else we have. Are you familiar with symbols of inequality? This is a symbol of equality. It tells us that something is equal. 2 plus 4 is equal to 6. Well, inequality shows us that things are not equal. Instead of being equal, they can be greater than. This is the greater than symbol right here. Looks like the beak at the end of a bird when it's closed. 8 is greater than 7. 7 is less than 8. These are symbols of inequality, and you need to get figured out, cemented forever in your head right now, before you turn off this video today, that when the triangle looks like that, it's greater than. When it looks like this, it means less than. Okay? Greater than, less than. It's wider open, it's bigger. The bigger part points to the larger number. The bigger part is pointing to the larger number. The little point points to the smaller number. 8 is greater than 7. 7 is greater than 8. So what we have right here now is an open inequality. For example, we have solve x plus 3 is less than 7 for the replacement set that contains 2, 3, and 4. So what we want to do here is we're going to take each one of these values and see what happens. 2 plus 3, is that less than 7? Yes. 5 is less than 7, so that's a true statement. What happens if we put 3 in for the x? 3 plus 3, is that less than 7? Yes. 6 is less than 7, so it works for 6 as well. Now what happens if we put in 4? 4 plus 3, is that less than 7? No, 7 is equal to 7. When you slash through the equal sign or through a symbol of inequality, that means it's not equal to. 7 is not equal to 7, 7 is not less than 7, rather than 7 is equal to 7. So this is not a part of the solution. Solve x plus 3 less than 7 for the replacement set 2, 3, 4. When you solve it, the solution would be 2 and 3. Because 2 gives you a true inequality. 3 gives you a true inequality. And 4 gives you a false inequality. Because it gives you a false inequality, it is not a part of the solution. So let me look and see. There's even one more that I'd like to do for you here. I really don't think that it's necessary, but let me do one more just for grins, just so I can be your favorite pre-algebra person. This says, solve the open sentences for the solution set for the replacement set, replacement set 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. We have 31 minus 9 is equal to 14 plus W. Okay? What happens when we're adding numbers together so that and seeing if they're equal? Can it be any more than one number equal to another number? No, 2 is equal to 2. 2 is not equal to 2 and 3. 2 is equal to 2. 31 minus 9 is what? 31 minus 9 is, this is not hard, is 22. Is 22 the same as 14 plus 1? No. 22 is not equal to 15. So we know 1 is not the solution. Is 22 equal to 14 plus 3? No. 22 is not equal to 17. 5, 7, 9 is going to be equal to any of those. Well, let's see. We can always add them. 22 is equal to, is it equal to 14 plus 5? 14 plus 5 here is 19. Are you seeing a pattern here? 22 is not equal to 19. We have an even number on the left-hand side. We've got odd, odd, odd. It doesn't matter if you do a 5, if you add a 7, if you add a 9. None of those numbers are going to equal 22. So, out of all of those choices, there's no solution. What's the number that we were looking for? Can anyone figure that out? 22 is equal to 14 plus what? 14 plus what is going to give you 22? 8. This is something that you look at. We say that we solve it by inspection. We look at it, we see that it's solved. As we move on, we'll learn to do the algebra for it, but the only solution to this equation here is 8. 8 is not included in our replacement set, so there's no solution because these are the only numbers we're allowed to pick. That's the end of section 1.3. We'll see you again next time.